So in this first set of examples, we will do 3 different triangles, and our goal will be to find the length that is in the numerator of the ratios. And to get us started, we want to split up this page into 3 different sections so we can do 3 different triangles. So let us start with the triangle on the left side here. And here's what you will always do first. You will identify the hypotenuse. So you can see that this is the hypotenuse. And then you look at, from the perspective of your angle, you figure out, okay, what is the side that I have? This, or that I'm looking for. This here would be called the opposite side. And this would be called the adjacent side. Now, I am looking for the opposite side, and I have the hypotenuse, and I have an angle as well, so I don't even need to worry about the adjacent. So here's a little trick that you can use to figure out which ratio you need to use to solve for your missing sides or angles. If you go back to the first page, you can see the ratios on the bottom, and what we will do is we will shorten them into an acronym. And so we will use the first letter of all these words, and we will make an acronym out of those. And you may have heard that acronym before. So if I take the first 3 letters, I will get the acronym SOH. If I take the next 3 letters, I will get CAH, and remember that opposite is always, the second letter is always in the numerator, and the third letter is in the denominator. So second letter is in the numerator, the third letter is in the denominator. So that should help you set up the equation, the ratio equation. And if I use these 3, then I get TOA, which gives me this. And when I say this together, I get the word or the acronym SOHCAHTOA. And so that's a very quick way to remember the ratios, the equations of those ratios, and which sides belong to which function. And so in this example, we will start by writing down that acronym. And the reason why is because we want to determine which one of these 3 ratios we want to use. After a while, you might be comfortable using or going towards the ratio without using this acronym, without trying to figure that out first. But at first, it is always a good practice to start with the acronym and then cross off or check mark the things that are given to you and the things that you are looking for. So, since I have an angle of 25 degrees, I can use my calculator to figure out the ratio. So for example, if I have 25 as my angle, I can figure out using the sine button what the ratio is. Or I can use the cos button to figure out what the ratio is between the adjacent and the hypotenuse. So in other words, I can figure out the ratio using my angles, my angle and the function on the calculator. So I can find out the sine ratio, I can find out the cos ratio, and I can find out the tangent ratio. And then from the perspective of the angle, we mentioned before already, A is the one we are looking for, so we are looking for the opposite side. So I will put a check mark into every opposite, or O, opposite side. And then the third thing is the hypotenuse. We have the hypotenuse. Why? How did I know that? Well, because that's across the right angle, right? This is the length that is across the right angle. And so that means this is what I can use to figure out that side. And so we will put a check mark into for all hypotenuse, for all h's. So that's all I have. I don't have the adjacent, there's no adjacent given to me, but I'm also not looking for it. I'm not trying to find it. Okay, I'm trying to find A using the hypotenuse and the 25 degrees. And so you can see from these three that we need to use the sine ratio. So now your goal is to set up that sine ratio using the equation from the previous page, and you can refer to it if you want. This is the equation, sine theta, and theta is just your general term for an angle in math. Sine theta is opposite divided by hypotenuse. Let's use O for opposite and H for hypotenuse. And now you insert your values. This was the angle, this is your opposite side, and this is the hypotenuse, and we will insert the values that we have for each one of those. So do I have the angle? Yes, I do. So that means I can write this as sine of 25 degrees. That is equal to the opposite. Now, do I have the opposite? No, I don't, but I have a letter for it, and so I'll use that letter instead of O, divided by the hypotenuse. What is the hypotenuse? Do I have that given to me? That is 7. And so now I have this ratio set up in such a way that I'm left with only one number that I don't know, one variable. So I can solve this equation for this variable. And to do that, I will need to multiply both sides by 7. When I multiply this side by 7, then this will cancel out and I will be left just with A on the right-hand side. And that's why I needed to multiply by 7. When I take the left-hand side and I multiply that by 7, because in an equation, when you change the equation, you have to do the same thing on both sides to keep the equation equal to each other. So, multiplying 7 by the sine of 25, that's where you will use your calculator to figure out what that answer is. And what we will do is first start by typing in the sine of 25, and that is 0.4226. And then I will take that answer and I multiply it by 7. And that is equal to 2.9583. Now, you can also go from the left to the right. You can just quickly say 7 times the sine of 25 and press the equal button. You will get the same answer. Some of your calculators need you to type in sine first and then the 25 degrees in a bracket afterwards. So figure out how to use your calculator with those functions. And if you have difficulties with it, make sure to let me know so that I can help you out with it. And so our final answer is going to be 2.96 units. 2 decimal places for the final answer, unless I tell you to round it to a different decimal place. So here is conceptually what you have done. You have used your calculator to change the 25 degrees into a ratio. So you've taken 25, and since you have the opposite in the hypotenuse, I want to use the sine ratio. So I figured out what my sine ratio is. And so that is 0.4226. Now, in other words, 0.4226 has to be some number, and we call that number A, the opposite, divided by 7. So what number divided by 7 will give you 0.4226? Well, if I take 3.5 and divide it by 7, I should get 0.5. 3.5 divided by 7 is half of 7. Okay? Anything bigger than 3.5 should give me something that is bigger than 0.5. Let's say, for example, I want to take 5 and divide it by 7, then I get something that is bigger than half. So what number divided by 7 will give me 0.4226? Well, it needs to be less than 3.5. And to figure out what that is, I will take 7 and multiply it by 0.4226. Figure out what is 0.4226 of 7, and that gives me that number. So if I now take this number a and divide it by the hypotenuse, so I take 2.9582 and divide it by 7, I should get that ratio again, 0.4226. So that's basically what you have figured out. You figure out the ratio with the angle, and then you use that to figure out what is the missing number. To begin with, though, it is a lot easier just to follow the procedure, and so that's why we will use the second example here, and we'll continue using the same process again and again. So we will start with the acronym SOHCAHTOA to figure out which of these three ratios I should be using. Now, the first thing that you need to identify is the hypotenuse. So I know that this is the hypotenuse because this is my right angle and this is the longest side of this triangle. So I do have my hypotenuse, and that is 12. And then the next thing is the angle. Since you will either always solve for an angle or you have an angle given to you, you will always check mark the first letters. Okay? So I do have an angle given to you, so I can figure out the ratio. And now from the perspective of this angle, what is the B side? Well, that is touching the 70 degrees. And so therefore this has to be the adjacent side. And so with the numbers that are given to me and the unknown, I can use the second ratio, which is the cosine ratio, to figure out what my B value is. Now the ratio is cosine of theta. It has to be equal to the adjacent divided by the hypotenuse. Cosine of theta is equal to the adjacent divided by the hypotenuse. So that's how you can use your acronym to figure out the equation. If you're not sure about that equation, you can always look back at the first page of this unit, at the previous page. So now I have the equation. Now I can use the numbers that are given to me and the unknowns to replace the theta, the adjacent, and the hypotenuse. And so this is what I get. The angle is 70 degrees, is equal to adjacent, which is called B in our case, in this example, divided by the hypotenuse, which is 12. Now you can take this one step at a time. You can figure out what the cosine of 70 degrees is. In other words, you can figure out what this ratio it has to be equal to. Or you can just solve for B very quickly by multiplying both sides by 12 and then finding the answer. On the left-hand side, we will take 12 and multiply it by the cosine of 70. So that's 12 multiplied by the cos of 70. And that is equal to 4.1042. So our B value has to be equal to 4.10. Just a quick note on the side. Remember that this should always be your longest side. The hypotenuse should always be the longest in this triangle. So if you get a number here or here that is longer than your hypotenuse, then you made a mistake somewhere and you need to check over your work again. All right, let's go to the last example in this case. And what we have here is an angle of 18 degrees with this length being 23.6 degrees and this length being C. We don't know this length, but we want to find it. And so we will start again with the acronym SOHCAHTOA. Since we have an angle, we can find out the ratios, the sine, the cosine, and the tangent. We can find that ratio using our calculator. And the next thing that you need to identify is the hypotenuse. So if you look down this right triangle, you can see that this here on the bottom is your hypotenuse. We don't have the hypotenuse. Some of you guys will quickly see that, oh, I can't use these two, then I need to be using the last one, the tangent. And that is correct. Now let me show you which one is which. This angle is the one that we are working with, which means that C is called the opposite to this angle. And this number, 23.6, would be the adjacent to this angle. Which means I have the adjacent and I have the opposite. I have the adjacent and I have the opposite, and you can see that from these three that the third one is the one that you need to be using because you have two of them and missing the third one of those. And so we will set up the equation again, just the equation for now, and then we will put in the numbers. So tan of the angle is equal to opposite in the numerator divided by the adjacent in the denominator. So here's the ratio set up. This will calculate the ratio, and if I multiply that ratio by 23.6, I can figure out what I had to divide by 23.6 to get this ratio. Or in other words, multiply both sides by 23.6. So C is equal to 7.67 units. And so that is how we solve for a missing number, missing length, when the length is in the numerator. All you need to do is multiply both sides by the denominator and you find out what your numerator is. In the next video, I will look at finding the missing length in the denominator. And as we go through these examples, you will find that they will become easier and easier because you are getting used to the different ratios and inserting the values into those equations and also be able to identify those values in your triangle.